In this lesson, we will learn about depth-based layering or compositing. Now, many times while compositing, we will need to combine multiple layers like the background and a foreground. Of course, we can just render a single image with everything inside it, but what if we want to separate the background and foreground into separate renders for render speed, or if we know one of them, we'll need to go through many revisions. We can try just using an alpha channel, but this becomes difficult when there is complex interactions between them, like aliens flying through a city. Now, if we render the aliens and cities separately, then we would have trouble compositing them together because the aliens weave in and out of the city buildings. We need a way to find which parts of our aliens are in front of our city and which are underneath. We can calculate which image or pixel needs to be in front if we have a depth map for both images. Let's first look at a depth map, which is a black and white mapping of the distance of an object to the camera. Now, there are two main types of depth maps, one where objects closer to the camera are darker and one where they are lighter. Depth-based layering is easier with objects closer to the camera being brighter. So we will focus on that type, as you can switch between types by inverting the depth map. Now, when a computer looks at a depth map, it just sees numbers. White is 1, black is 0, and the grays all correspond to a number. Now, of course, this is within the normal dynamic range, but it does apply to most depth maps. Now, let's say we have another depth map, which looks like this. Again, white is higher than black. How can we tell which pixel is closer? Well, if we are going bright is closer, we can subtract one map from the other, and any pixels that are still positive will be closer, and therefore the ones we want to keep. So to find if image A is above image B at any pixel or at a specific pixel, take image A's depth information and subtract image B's depth. The resulting image will be positive wherever A is above B, and negative wherever B is above A. So we can use this as a mask or matte to cut out image A, and then they will be correctly layered. Now, breaking our renders into multiple layers has some downsides. Any light or shading that needs to pass between the two layers will not happen unless the geometry is on both layers. This includes shadows, reflections, refractions, color bounce, ambient occlusion, and so on. This is the main downside to using this technique while we're rendering. Now, of course, if you do not need to use any of these techniques, you can use this very easily. So now that we know the basic concepts behind depth-based layering, let's jump into our compositing application and see how we can do it.